Okay, so what we're going to do now is use these trig ratios, sine, cosine, and tan, to solve for unknown sides in a triangle. So what you'll notice in each of these questions, we've got one known side, and we're trying to find one of the other sides. If I had two known sides, like if I knew that this side here was 7, I could find x just using the Pythagorean theorem. But I don't have that piece of information. But what we can do instead is use our trig ratios to solve for these unknowns. So what we're going to do is, first of all, identify which trig ratio is going to be relevant for us. So for this one here, if this is my angle that I'm interested in this corner here, then what I've got is, well, I've got the hypotenuse regardless of what angle I'm talking about. But then if I follow the labeling, x is opposite of the 40 degrees. So I've got opposite and hypotenuse. And I find the trig ratio that uses opposite and hypotenuse, that is my sine ratio. So I'm going to set up sine. And so I'll just set up the equation. Sine theta is opposite over hypotenuse. And now plug in the things that I know. I have sine of 40 degrees is opposite, which is x. Well, I don't know, but I know what I want it to be as far as what's in that picture, over 12. And I should be able to now solve for x by just bringing the 12 up to the other side. And this is just calculator work. So I do want you to be really careful with what you punch in your calculator. Look around the screen. If you have a scientific calculator, you want to look for either like a D written somewhere or like a DEG. If you see that, that means that your calculator is set to degrees, which is good because 40 is written in degrees. You might also see some things like a R or a G, or like the word rad or grad. That's bad, and you're going to need to change the settings. So it depends on what type of calculator you have, but you have to figure out how to get your setting into degrees. So I recommend trying to make sure that you are able to get what I get from this when we plug this in. But the calculation, it should just be 12. And then I'm going to hit the sine button. So all of these numbers are going to be stored in your calculator. And then I'll hit equals. And that should give me my, my sine 40. And then I'm just multiplying it by 12. And I'm getting 7.71. I rounded it to 2 decimals. I will always be specific in your homework or tests or quizzes or anything how many decimal places I want it rounded to. But yeah, for now, I'll probably just do 2 unless it's obvious to do something else. Yeah, so x is 7.71. I mean, that kind of looks okay with the picture. If that length there is 12, roughly 8, it looks all right. So that's probably good. All right, so we do the same thing for b. I'm going to look at, this is my angle information that I have. I don't have a hypotenuse. And if we look at what we've got, x is the opposite, and 14.1 is the adjacent. And so the trig ratio that uses those two things is cosine. That little COS is just short for cosine. And so I set up my cosine. Cos theta is adjacent. Wait, no, that's not cosine. I made a mistake. It's tangent, obviously. Tangent. Write that in red. Fooled you. Tangent. As I was writing it, I was realizing there's supposed to be a hypotenuse there. Okay, so tan theta is opposite over adjacent. And so plug in what we've got. Tan of 21 degrees is the opposite, which is x, and the adjacent is 14.1. So I can solve for x by bringing the 14.1 up and multiplying it by that tan of 21. Your calculator should have a tan button right near the sine and the cos buttons. And so this calculation, 14.1 times tan 21. And so I'll get x is about 5.41. And then note that in this problem, I have a little meters for that one length. That means that all of my lengths should be measured in meters. So I'll add an m for my x value there. One last one. Same thing. I'm going to maybe do this better than last time, though. We've got our 38, and we can see we have our adjacent, and I've got my hypotenuse. This is the cosine one for realsies. Cosine, yes. Ka. Okay, so set it up. Cos theta equals adjacent over hypotenuse. Cos of 38 degrees is 3.4 over x. So solving this one is a little bit uglier. So what I'm going to do is bring the x over here by multiplying it up, but then I also need to bring the cos down to isolate the x. So I might just, maybe I'll just do that in two separate steps. If I want to get rid of the x on the bottom, I'm going to get x times cos 38 degrees is 3.4. So x is 3.4 divided by cos of 38. And so plug it in, cos 38. And I get 4.31. Right, it should make sense that it should be bigger than the 3.4 because it is the hypotenuse. That should be the biggest side. And so yeah, so this is how we can solve for any of those unknown sides. This is like that last one is as hard as the math will get for these.